Hey there, medical students! Today, let's dive into the essential tips and techniques for estimating glucose levels in cerebrospinal fluid or CSF. First things first, glucose in CSF is rapidly destroyed once the fluid is collected, so it's crucial to carry out glucose estimation as soon as possible. If there's likely to be a delay, the CSF should be preserved in fluoride oxalate to maintain its integrity. Now, any method used for blood glucose estimation can also be applied here. However, keep in mind that the glucose level in CSF is typically lower than in blood and may be further reduced due to disease. Therefore, the volume of CSF used in the test should be twice that of blood used in the same procedure. For a detailed method, refer to the section of chemical pathology on page 265 in your textbook. Speaking of diseases, let's look at some CSF findings in various conditions. For normal CSF, you'll see it clear and colorless with a glucose level between 2.5 to 4.4 mmol/L. In choriomeningitis, the CSF appears clear, but with increased lymphocytes and normal glucose levels. Purulent meningitis? The CSF turns turbid with polymorphs and a decreased glucose level, often below 2.5 mmol/L. Tuberculous meningitis gives you an opalescent CSF with increased lymphocytes and glucose levels ranging from 1 to 2.5 mol/L. Encephalitis usually shows clear CSF with potentially increased lymphocytes but normal glucose levels. Brain abscess, on the other hand, makes the CSF turbid with polymorphs and potentially decreased glucose levels. In syphilis, the CSF remains clear but with increased lymphocytes and normal glucose levels. Tumors can lead to xanthochromia with significantly increased lymphocytes. Subarachnoid hemorrhage results in bloody or xanthochromic CSF with increased red blood cells, while disseminated sclerosis typically shows clear CSF with normal glucose levels. Finally, for a reliable measurement, make sure to prepare a calibration curve for CSF proteins. Here's a quick guide. Tube 1, 0 gl CSF protein, 1.0 milliliters saline. Tube 2, 0.2 gl CSF protein, 0.9 milliliters saline. Tube 3, 0.4 gl CSF protein, 0.8 milliliters saline. Tube 4, 0.6 gl CSF protein, 0.7 milliliters saline. Tube 5, 0.8 gl CSF protein, 0.6 milliliters saline. Tube 6, 1.0 gl CSF protein, 0.5 milliliters saline. Tube 7, 1.2 gl CSF protein, 0.4 milliliters saline. Tube 8, 1.6 gl CSF protein, 0.2 milliliters saline. Tube 9, 2.0 gl CSF protein, 0 milliliters saline. And that wraps up our essential tips and techniques for CSF glucose estimation. Remember, quick and accurate analysis is key. Happy studying, and until next time, keep those brains sharp.